Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us to my channel of Sciences and Mathematics. I'd like to request our members to kindly subscribe to our channel and click that notification button so that we can be getting updates on various uploads on topics of mathematics, physics and chemistry and some areas of application. So in this specific discussion, we're going to have another concept of the discussion of vector differential operator. And today we're going to look at the concept of the curl. Now in our previous discussion, I had mentioned the concept of this particular application of the vector differential operator that you had given us del. And we said that del can be represented as dx I plus d dy j plus d dz. Okay. And we said these are these are vector quantities in the rectangular coordinate system. Now we said that this vector operator is going to assist us define three specific aspects of the gradient, divergency, and the curl, which are going to find application in various areas of volume integrals and some areas of rotational properties of some vector fields, and of course some areas which we're going to see later. So in this particular case, the curl is one of the, so we have looked at this specific concept. The curl is one of the derivatives of this vector differential operator, and then we're going to see that we can be able to represent this specific aspect of curl using this vector differential operator. Now we're going to assume that we have a specific what we refer to as a unique function that can be represented using this specific letter that we had mentioned that I'm going to give as v. So we can be able to use an letter that can just be able to use v. So we say let v be a defined a point, or rather a defined function or a unique function that is going to be defined and differentiable a point in a particular region in space, and therefore we're going to use that one to describe the concept of a curl using this particular v, which is going to be a vector field. Then we can be able to define the concept of a curl using del v by giving it as del cross v. So in this case, therefore, we're going to see that we can be able to give v in terms of its components, as I said. So v is going to be represented as v1 plus v2 plus v3, but this is going to have the components of I, j, and k, which are going to be vectors given as such. So if you try to have this specific concept for del and v, then del cross v, then therefore that is going to define what we refer to as a curl, or sometimes we're going to refer it to as the rotation of v. So therefore this one can be given as del cross v, or rotation of v, or the curl of v. So in any case, if we have this specific denotation, three denotations in our various texts for the del cross v, rotation of v, curl of v, bearing in mind that this is a vector field which is differentiable and defined at a point in space, then therefore the definition for these ones are going to be correct in any of our discussion that we're going to have. So in any case, if we have these specific letters, then therefore we can be able to define the concept of a del cross v by having a cross of their specific components. As we said, this is going to be d over dx plus d over dy, j plus d over dz, k, and then this is going to be combined with these specific components of v, where we're going to have v1 I plus v2 j plus v3 k, whereby these ones are vectors. So therefore from the basic algebra of this specific part, therefore we're going to see that you can be able to define this one using that specific concept that we've done using matrices, whereby we're going to have the I, j, and the k components, and then we're going to have d over dx, d over dy, and d over dz, and then we are going to have the last row represented by the components of V1, V2, and V3. So this is going to give us what we refer to as a vector quantity, whereby from the basic operations we're going to hold this specific I, and we delete the ith column and of course this specific row, and we're going to multiply the components of this specific V for dy and V3, and we're going to obtain d V3 over so this is dV3, and then this is going to be over dy. So if we multiply this specific component together with this one, we're going to obtain dV3 over dy, and then minus dV2 over dz, dV2 over dz, and this is going to give us the I component of this specific curl. So, and then next we're going to have another one which is going to give us a j component for this, which is going to be, we delete this column and then this row, and then we are going to have that is going to be dV1. So this is going to be this one and this one. So this is going to be dV1 all over. The next one is going to be that one, which is going to give us so this is going to be over dz, and then this is going to be minus with dv2 over dx, dv2 over dx, and this is going to give us the j component of that specific curl. And lastly, I'm going to use this space. So lastly, we're going to have, so the next one, instead of addition, we're going to have a minus, but it's due to the different sign that's going to be in between here, and therefore it's going to be given as an addition, which is going to be this specific column for the j component deleted with this one. It's going to be giving us a dv2 all over, so this is not a square but v2, so dv2 over dx, and then minus dv1 all over dy, and this is going to be the k component of this specific curl. So we can be able to define the concept of a curl using this specific the cross or rather the cross between this function of the differential operator del together with this specific or unique function in space that is defined and differentiable by having a cross over this del v given using the specific components, and therefore we are going to use this strategy and then of course evaluate it as I've given it in our last step as shown. So this was our last bit, and of course I hope that it's going to assist us in its various areas of application. So in any case, if we're trying to define the concept of a curl and trying to find specific areas, if we come across especially areas of application, especially in rotation of vector fields, then it's going to be relevant for us, and I'm going to always have a reference for these 3 videos for the curl, divergence, and gradients, which are going to assist us, of course, to evaluate similar areas or similar problems in these respective areas of application. So that is it for now, guys. Bye. God bless you.